Nature is beautiful and complex. It can produce nearly any material and functionality we can imagine. Yet most manufacturing is based on breaking these complex structures down with chemicals and high temperatures, only to rebuild them into everyday objects. But what if we could turn this around? The EU Horizon project, BioUPGRADE, is pioneering an effort to leverage the power of nature to create new biomaterials by upgrading the natural resources instead of degrading them.
We're opening a new paradigm shift on how to use lignocellulosic fibers. We really want to utilize the excellent assembly and structure properties of the biopolymers in biomass intact as they are.
And be smarter with the way we can convert these existing materials into textiles, into packaging products, into personal care products.
Scientists in Finland, Spain, and Sweden are collaborating in a pursuit of improving biomaterials development by creating new circular processes using biocatalysts.
Normally, enzymes, they are used to hydrolyze the biomaterials, but in this case, we try to keep the material as intact as possible so that we just open the structure and give a better reactivity.
To further improve the enzymatic processes, the BioUPGRADE project is exploring the industrial use of recently discovered proteins called expansins.
These proteins don't add new chemical functionality into fibers, but they add new mechanical properties into fibers. We don't know exactly how they work yet, but expansins, what they do is they disrupt non-covalent interactions between neighboring fibers, causing the fiber to then swell. And this is an example of cellulose activation. And that process is really important for dissolving cellulose in a way that lends it to spinning, an important first step to making sustainable textiles from wood-derived cellulose fiber.
While nature can provide us with expansin-like proteins, the scientists at CIC BioGuine are not stopping there. Using powerful computational tools to accelerate enzyme optimization, the scientists in Spain are conducting ancestral reconstruction to resurrect ancient proteins. In other words, reverse engineering evolution.
Ancestral enzymes are like a Swiss Army knife. They're not that specific, but they can do a lot of things. Quite often, those ancestors show interesting properties such as improved functions, improved efficiency, improved stability, which are the basis of the new biocatalysts that we are actually using in the project.
Besides expansins to improve the physical properties of natural fibers, the BioUPGRADE team is developing enzymes that enhance fiber properties through targeted introduction of new chemical functionalities. Finally, all these different proteins will be used together for the upgrading of biomass.
We are envisioning application demonstrators in 3 areas that are very relevant. One is textiles, a very huge application area. The second one is health and personal care. And the third one is conductive inks for the electronic sector.
For industry, these new enzymes and expansins offer many benefits.
Of course, we are trying to minimize the energy consumption, for example, so lower temperatures, protein dosage, pulp consistency. There is a lot of optimization to do. And then the most important thing to understand that, okay, what does our protein do in the structure and how we can take the most benefit out of it.
Developing and commercializing these next-generation biomaterials will require the combined efforts of scientists and industry that operate at different scales, as well as multidisciplinary collaboration to leverage the power of biology in catalyzing a genuinely sustainable circular bioeconomy.
What I see as unique about the BioUPGRADE project is we've come to an alignment of scales, an understanding of what is possible for enzyme discovery, what scale of protein production can we do at the discovery stage, and how can we characterize our materials that align with those initial limitations.
The fascinating world of biocatalysts and enzymes holds vast potential in replacing intensive manufacturing processes and petrochemicals, while promoting sustainability, and preserving our precious natural resources.